Okay, this is the M1 paper from October 2021. This is question number 1 that we're going to look at. And this is a moments and equilibrium question. As you can see, what I've done just quickly is to draw out a template for the diagram here, just so that I can put all my lengths, forces and everything on nice and clearly when we're going to be working out our moments. So let's read the question. It says it's a non-uniform rod. Okay, so the mass won't necessarily be acting at the center. Length's 9 meters and the mass is m kilograms. So the rod rests in equilibrium in a horizontal position on supports where? Okay, so I've got AC equals 2.5. Let's put that on the diagram. That's this length here. I've got that dB is equal to 2 meters. That's that length there. So at the moment, I know I've got 4.5 left in the middle there. Let's read the rest of it. So the magnitude of the force acting on the rod at D is twice the magnitude of the force acting at C. So yeah, the first thing I'm going to do is put on my reaction forces. So I've got a reaction force here and a reaction force here, which I'd normally call RC and RD, but they're actually telling me that this one is double the other one. So what I'm going to do is call the reaction at C R, which means I can call this one 2R. So it's one of their ways of actually just getting rid of some variables out of the question. Now, the other thing they say is that the center of mass is D meters from A. So what that means now is I can put my weight acting down here, mg, and I can say that this length here is going to be equal to D. Okay, they want us to work out what the value of D is. So pretty standard style question. What I'm going to do is I'm going to, first of all, look at the forces acting vertically, and we're in equilibrium, so I know that they'll balance out. And then I'm going to decide to take moments. When I take moments, I can take it about A, about C, about there, about that. I can take it about anywhere I want. So I'll make a decision based on what I've got as I'm going through the question. But the resolving vertically is nice and simple, so let's get that done straight away. Tell the examiner what you're doing. So I'm resolving vertically, and I'm going to get that R plus 2R is equal to mg, or in other words, 3R equals mg. So that's really helpful, really going to be useful in my next part. What I'm now going to do is to take moments, and when I'm taking moments, I just need to be aware, do I need to take moments about this one here to get rid of the variable R? Well, there's no point, because even if I'd got rid of the variable R there, I've still got 2R over there. So it doesn't matter about taking moments about C or D. They're not particularly going to help me. I'm still going to have the same number of variables in there, in which case, in order to simplify this one, it makes most sense for me to take moments about A. You can take moments about other things, but for me, there's my rationale behind what I'm going to do. So I'm simply, and I've got to obviously explain it to the examiner, take moments about A, because there's other ways I could do this question, but I'm choosing to do that one there. And again, we know we're in equilibrium. So what it means is that mg times D, which is the only force, or the only turning point, the only moments going clockwise, is going to be the same as R times the 2.5 and then 2R times this full distance here. So before I do either of those two things, let's just make it clear that because the whole length is equal to 9, this bit here must be 4.5 meters, giving me that 2R is going to be multiplied by 7 when I'm doing it. So taking moments about A, R times the 2.5, 2r times the 7, that's going to balance out with mg times d. And now what I can do is kind of use that information here and substitute it in there. So it's going to be nice and easy to be able to work this one out. It's a first question of a paper, shouldn't be overly complicated. So I've got 16.5r on this side, and here, instead of having mg times d, I can now have 3r times d. So the r's can cancel, and d is simply going to be 16.5 divided by 3, which works out to be 5.5 meters. Okay, so a fairly straightforward question number 1. Hopefully that makes sense.